So great having you all here today. You are here for Planning, Design, and Development in the Global South, the how-to for people and the planet. And we're going to be talking for the next 90 minutes about carbon mitigation and resilient solutions in the built environment. I was thinking earlier today, okay, better? I was thinking earlier today, climate change is at once 100% global and 100% local. And that's interesting when you think about it from a buildings perspective. A changing climate, you see the effects locally on the ground. And buildings are exactly the opposite. Our cities and buildings are hyper-local, and yet the impacts that they have are global because of the carbon emissions that they create. So I wanted to just start this session by taking a minute to ground ourselves in the local. And I found this beautiful poem by a Bedouin poet from this region. And I'm going to read it, and we're going to just think for a minute about what our special places are. O Valley, your love is a home for the soul's joy. Whenever I see you, my heart grows. I come to you in longing, full of pains. My soul returns to me as I approach your grounds. So I love that. Your love is a home for the soul's joy. So I'd like to invite you for just a minute, if you're comfortable, to close your eyes and take a deep breath and think about the place that is the home for your soul's joy. So I'm Lisa Richmond. I am a senior fellow with Architecture 2030, and we, along with ASHRAE and the International Network of Women Engineers and Scientists, are the hosts for this panel this afternoon. Architecture 2030, sorry, I'm juggling too many things with my hands. Architecture 2030 works to rapidly decarbonize the built environment, convening industry leaders in architecture, engineering, planning, landscape architecture, and construction around a collective commitment to zero carbon. ASHRAE is a global society advancing human well-being through sustainable building systems, energy efficiency, and indoor air quality. Through research, standards, and education, ASHRAE shapes tomorrow's built environment today. And the International Network of Women Engineers and Scientists is a global network of women working in the STEM fields that builds a better future through full and effective participation of women and girls. And the thing that all three of our organizations have in common is a belief that the design of our built environment is going to have a major and potentially defining impact on the future of our climate and our planet. I'd like to just take a moment of gratitude and thank the United Nations and our hosts here in Egypt for allowing us to talk with you today. So I'm curious in the audience, how many of you are working in a field related to buildings and cities? Everybody, all right. And how many of you are already familiar with the statistics around the impacts of building on carbon emissions? All right, very well-educated audience. So we all understand how the manufacture of building materials, building operations, and construction process itself are a major source of greenhouse gas emissions. That means that the design of our buildings, landscapes, and cities has a tremendous impact. You probably then are already familiar as well with the fact that the majority of the built environment in Africa, Asia, and the Middle East hasn't been built yet. The majority has not been built yet. So that is a lot of design, building, and construction that's going to happen over the next few decades to do several things: to close human development gap, to accommodate growing populations, and to adapt to the increasing impacts of climate change. And that's a huge opportunity to elevate the unique assets, resources, and knowledge of those that are leading design in the Global South. And those are the folks that we're going to hear from today. Solutions that are being applied right now on the ground in Africa, Asia, and the Middle East. And we're hoping that you will leave with a sense of possibility and signals about what the future might hold. Thank you, Pamela. We're lucky that designers are solutions-oriented people. And all of our panelists talked with me about that. And we recognize that an upfront investment in design thinking can pay huge dividends. We don't need new technologies. We don't need to wait for something to be invented. In often cases, we don't even need to invest more money if we're thoughtful at the beginning of the design process and make good decisions. That has a very, very powerful impact on both the carbon and resilience dividends that development will pay back. So before I introduce our panelists, I'm going to just share a brief video, keynote video with you by Architecture 2030's founder, Ed Mazria, and Erin McDade, who is the program manager at Architecture 2030. Ed Mazria is the founder of Architecture 2030 and has galvanized the building industry to work towards a zero carbon built environment. As an internationally recognized architect, author, researcher, and educator, he's redefined the role of architecture, planning, design, and building in reshaping our world. And Erin McDade leads Architecture's 2030's wide-ranging public policy and embodied carbon initiatives. Her work focuses on data-driven solutions for the building sector.
Hi, everyone. This session is the how-to for planning, design, and development in the Global South, presented by myself, Erin McDade, and Edward Mazria of Architecture 2030. By 2040, population in the Global South is expected to increase by 1.21 billion people, or 90% of the total expected global population increase. 50% of this growth will happen in Africa, another nearly 30% in the Middle East and India, with the remaining Global South increase in Southeast Asia, Latin America, and the Caribbean. In order to meet the needs of this significant population increase, the Global South will need 403 million new housing units, 3.63 million hospital beds, 522,000 new schools, and of course, enough infrastructure to support all of this significant development. Currently, the built environment is responsible for nearly 50% of total global annual emissions. So how we plan, design, and construct the built environment may very well determine the fate of the planet. But we have the tools and strategies to plan, design, and build sustainably, equitably, and with zero carbon emissions today. And with that, I'm going to pass it to Ed to tell you how we're going to achieve this.
Thanks, Erin. So how do we achieve a zero carbon built environment? Well, it's a two-step process. Step one is planning, design, and construction. Step two is adding the renewables to get us all the way to zero carbon. So planning, design, and construction. Those are strategies that we use to get the 70 to 80% reduction all the way to zero carbon. That's everything from growth boundaries in urban areas to transit development, to walkable communities, urban agriculture, everything down, way down to the building scale, the form of a building, where you put the glass, how you shade the glass, the materials we make the building out of, the construction types, passive heating, cooling, and daylighting strategies. All of that will get us 70 to 80% of the way to zero carbon. And then to get the other 20 to 30%, we add renewables, everything from on-site solar to utility scale solar, wind, hydro, and geothermal. And we know now that solar is the cheapest electricity in history. That's confirmed by the International Energy Agency. All of the strategies to get to the 70 to 80% reduction are contained within the 2030 palette. You can find it online at 2030palette.org. It's a free program. It's everything from regional strategies, cities and towns, district strategies, site and site development strategies, all the way to building design and building construction material strategies. You can find that all at 2030palette.org, and it's free. Here's one strategy, for example, heat island mitigation. You can see there are tools and resources. There are links to these tools and resources. And there's also in every strategy a rule of thumb. So in this case, if we want to reduce the heat island effect, if we increase the canopy in a urban district, for example, by 10%, we can reduce the midday maximum temperature by 1 degree C. So it has all sorts of other strategies for heat island mitigation. This one is transit-oriented development, for example. How do we develop for public transit? Well, we could establish transit-oriented development. We can establish those stops within 400 to 800 meters walking distance within an area, so that you increase the ridership on public transit, and this way make it financially viable. Other strategies, for example, at the building scale, what is the optimum form for daylighting a space so we don't need any lights on during the daytime, especially in day use facilities? Well, the rule of thumb is 4.5 to 9 meters. That's how much daylight you can throw, for example, from a window on a outside window in a space, and you can do it from both sides. The 4.5 meters is for task daylighting, and the other 4.5 further inside the building is for ambient daylighting. Here you can see task lighting from both sides. So this is a 9-meter wide floor plate, and you can see beautiful daylighting in this hospital in the global south. And here you can see a much wider floor plate, probably 18 meters. So you can see 4.5 from each side for task daylighting. That's where you're working and doing all the other things. And for circulation and storage and things like that, the other 4.5 coming in from both sides behind that is for ambient daylighting. So you can create a wider floor plate. So that's the guideline, the rule of thumb for daylighting design. This is double roof, and here you can see a beautiful double roof on a school. And the rule of thumb is in hot climates, you can incorporate a double roof separated by an air cavity from the roof of the building, and that shades the entire roof of the building. And if you extend that roof line over, you could shade the walls also and outdoor spaces. It's beautifully done in this school in the global south. You can also extend the roof line over multi-story buildings, for example, and use a double roof in that case. And here you can see a nice example of shading the roof and the outdoor balcony spaces in a multi-story building. Now, solar energy, actually energy, is distributed free to every place on the planet. You don't have to dig anything up. You don't have to clean it. You don't have to transport it. You don't have to build facilities to burn it. This is energy, solar energy, that's distributed free to every square meter on the planet. In the global north, it's roughly 2.6 to 3.8 kilowatt hours per square meter. That's how much energy you get on a square meter on a daily basis. That's a daily average. But look in the global south, it's 5 to 6.2 kilowatt hours per square meter. That's almost double the amount of energy that you get free to every site in the global south, almost double what you get in the global north. So it makes sense to use that energy. And so we could say that the richest places in terms of energy distribution, free energy distribution, is in the global south. So I'd like to thank you all for attending the How To for People Plus Planet. Erin and I would like to thank you very much, and we'll now continue with the rest of the program. Thanks again.
So thanks to Ed and Erin. And now I would like to invite our panelists to join me on stage. Any seat is fine. Doesn't matter. Actually, so with us today are designers that are working at all scales of building, from the individual building all the way up to city design, and we're going to go from larger to smaller. And I'm going to introduce each speaker individually right before they speak. So our first speaker is Ghaith Tibi. Ghaith is an urban planner and sustainable development advisor at Arup, based in Dubai. He's got extensive experience in city planning and sustainability projects in the Middle East. As a strategic and integrative thinker, he believes in addressing complex urban challenges holistically and systemically. He digs deep to consider all aspects of an urban context, physical, economic, and sociocultural, because he believes we can only solve problems if we understand their root causes. And he's joining us virtually today.
Good afternoon, everyone. It's a great pleasure to be with you remotely to talk about cities and sustainable cities, more specifically at the COP27 this year. Let me start by thanking Architecture 2030 and partners for hosting this panel. It's a great honor to be on this panel and talk to you today about sustainable cities. My name is Ghaith Tibi. I'm an urban planner and sustainable development advisor based in Dubai, and my experience over the past many years has been on cities advisory work in the Middle East. And today I want to talk to you about 5 key principles that I think are needed to plan in a more sustainable way future cities. The first principle is about the establishing of the need for building new. And I think it's really crucial that we think about existing cities and the capacity within those cities to accommodate more people if we rethink about how we currently use the existing cities we have, how much space that we can really reuse, repurpose, how much buildings that we can refurbish, repurpose, or even change their form so they're more able to accommodate people and leverage existing infrastructure and the spending and the investment that's gone into building those cities. I think it's really crucial before we think about building new to check in our cities where are those opportunities that we can tap into to leverage what we already have in place before we start spending money, land, resources into building something new. The second principle is about how much do we need to build. Assuming we establish that there is a need to build new, I think the second question should be how much do we need to build? Because of course we all know how difficult it is to project growth, be it economic or population. It's also difficult to predict when that projected growth is going to happen. And so we really need to be careful about those projections and those assumptions that we use every time we're planning to build a new city. So I would encourage us to think really hard about how much should we build, when, before getting into the mode of production, the mode of expanding the cities we have or building completely new. Really, I think we should be thinking hard about those projections and be really careful how much we build before it's too much, too late to go back on the investments we've made and the built environment we've invested in. The next principle is about where should we build. That's really a crucial question. And I think it's one of the key questions that have significant impact on the environment, but also on the economic and social aspects of our cities. And I think this is one where a lot of times, even cities with best intentions got it wrong and chose locations that did not support their aims and the vision they've set out for their project. And we ended up with almost ghost towns in the middle of nowhere with buildings that were designed to be extremely efficient, but because of the location of those cities, they were almost abandoned cities, and a lot of money, resource went to waste. So it's critical that we think about where we locate those city expansions or new cities of the future. And I think a starting point would be, let's stay as close as we realistically can to existing established cities, to leverage the existing infrastructure, to leverage the existing social networks, to leverage the existing community and business networks, and avoid starting from scratch, because I think we all know that cities take a lot of time to get established and to evolve. And so the best way, I think, for new cities to flourish is to have to build on the existing cities and on the successes of the existing cities instead of starting from scratch. The fourth principle is about the build form. What build form should we use when we build new cities? And I think this is, again, really key, and that's why it's one of those 5 principles I'm sharing with you today. What form we use determines a lot of things on the investment we're going to make, monetary investment, but also on the land uptake, also about the social and economic qualities of those cities. And so it's really important that we get this right, and it will be different for different cities, different contexts. However, there are common threads there that we always, as planners and decision makers, we need to take into account. We need to think about how much land we have, how much resources will be spent, depending on what built form we choose to build. And so I think this is really key, and it has to be considered every time we're thinking about building a new city. And I think we have plenty of examples around the world of different built forms and how those impacted people's lifestyles, people's livelihoods, the environmental conditions of those different built forms on their surroundings, and over time how those evolved. So it's really important principle that we should take a lot of care of when we're thinking about building new cities. The last principle is about dealing with the impacts, reducing the impacts of what we build. Because let's face it, we will need to build new cities. We will need to build expansions of the existing cities. And so when doing so, and after we've gone through the 4 principles that I just ran through very quickly, I think the 5th principle is about we still have to do what we can, the best we can, to reduce the impacts of what we decide we really have to build. And that's to do with environmental impacts of what we build, but also the social and the economic impacts. Because again, I think our cities are much more complex than what some might think, and therefore focusing only on the environmental side of things is not exactly the best way forward or the most sustainable approach. So I think we need to keep in mind the social, the economic, and the environmental impacts of whatever it is we decide that we're going to build, and try and reduce those impacts as best as we can. On this slide, I really tried to summarize the 5 principles I ran through today with you. And so I think if we think about it, we're talking about first, let's try and build nothing if we can. That's really the starting point. That's the best way to reduce every impact we possibly will have if we build anything, right? So if we build nothing, there won't be any environmental, social, or economic impacts. So let's try and do that. That's the easiest way to reduce our impact, if we can. But again, realistically speaking, we will need to build new, and we will need to expand some of our cities. And so when we have to do that, then let's try to build less. Let's try to build less, because this means we have less impact if we do build less. And then let's build clever. Let's think about where should we build. Let's think about how should we build efficiently. And that's the fourth principle. Let's build efficiently. Let's pick the form of the built environment that's most efficient and effective in addressing the real needs of our communities and the population growth. And lastly, let's try and minimize the waste and resources, be it monetary or natural. Let's try to minimize the impacts of our development and our new built forms across the global south. Those are really the 5 principles I wanted to share with you today, and I hope you find these useful, and I look forward to having more discussion around those points in a few minutes. Thanks a lot. Great to be with you. Thanks again, Architecture 2030, for hosting this panel.
And Ghaith will be joining us live for Q&A from Dubai. And we've got a wonderful twofer because his wonderful colleague Amina Desai is with us as well. She's an urban designer at Arup's Johannesburg office, and where she's focused on how we can meet Africa's growing urbanization challenge sustainably and in a manner that's inclusive. So the two of them are going to be available to help us with Q&A. Thank you. And now it is my great pleasure to introduce a force of nature, Kotchakorn Voraakhom. She's a landscape architect from Thailand who designs green public spaces that tackle climate change in dense urban areas. She's chair of the Climate Change Working Group at the International Federation of Landscape Architects and founder of the Porous City Network. Her work's intimately connected to the place she's from, and her design practice deeply engages climate-vulnerable communities. And she is a powerhouse who lives her belief that actions speak louder than words. So, Kotch, do you want the handheld or?
Yes. Can I have a slide? Thank you. Sawadee ka. Thank you, Lisa, and thank you, Architect 2030, and thank you, all of you, to be here with me. Slide, please. Should I be at the podium? So, okay, maybe better. Yes, love to be standing up. So yes, my name is Kotchakorn. I'm from Bangkok, Thailand, and we are representing the landscape of IFLA, International Federation of Landscape Architects. We represent 77 nations, 27,000 of landscape architects around the world. It's a lot of us. And this is our team, and Pamela is here with us as well. And we actually a profession, and I myself was listed as a 15 women leading against climate change with many other leaders from other professions. And last year was on the speech of Sir David Attenborough and about how we can do with our global south. And nature-based solution. Today at COP is a Biodiversity Day. And we talk so much about nature-based solution, ecosystem-based solution, but for us, it's a landscape architecture. We have been doing this for decades, centuries. When you talk about architects, we know exactly who we like. But when we talk about landscape architects, we can't think of any. So what we did is actually, this is from the home state, Central Park, Highline, New York, and many more. This is the profession, how we start this nature-based solution. And I'm very glad that one of my parks from the Global South, from Bangkok, was listed from the UNEP as a case study of making city and town livable lesson from Bangkok, and actually a case study for many cities around the globe. This is Bangkok. This is the impact from 2050, 10 years ago, but this is a recent one. So the impact of climate change really make us understand differently how we understand about the climate change. And this is me, myself, experiencing flood when I was super young. And this is what is flood look like when we experience right now. This is our daily life, very normal, with only 15 minutes of rainfall. Sea level rise, PM 2.5, 15 million people living in such on the wetland. I think we, at the point, either we adapt or we die. So this is the park influence from the climate situation in Thailand, and it's actually really simple. With the nature-based solution, we just incline a flat city and collect every drop of rain. And with the green roof, wetland, detention pond, and you can name it with the native plants. This is actually nature-based solution. You have to learn from nature, and the nature itself will figure out. But with that, I'm very honored that Mr. Antonio Guterres, of course, #1 here at COP, every COP, he actually went to the park and giving a big support to this Global South solution. It's also benefits to people, and I'm sure that when you include architects, engineer, but don't forget us, landscape architects, we actually can implement things better. The role of us in mitigation, and we only been taught through adaptation. But when we heard about politicians talking about 1 million trees, let's plant a lot, but it's actually destroyed so many things. Maybe it's good in the beginning, but these plants soak up so much water that many of the solutions can actually create more problems in the future. And we name it as nature-based solution. And this is another report from the trouble of the tree afforestation in Africa. So we have to be very specific because we work with ecosystem. We're not working only about quantity. We work on the quality of how things should be. So landscape architect, integrative mitigation and adaptation, and that's what we need for the Global South. The inland flooding, this is very normal situation in the Global South. Dams, concrete, engineer solution. This is what the Venice of the East look like nowadays. And this is how we did, working with the governor of Bangkok to really change all this canal, 1,600 canal around Bangkok, it look like this. So this might be very normal solution for the global north, but for us, this is like innovation. This is the first step, and we actually need more help on scaling up this thing with the nature. Urban heat island is we actually come from the tropical country. You think like we are very used to heat, but actually all this heat actually increasing the use of the energy in the building if you don't think through the landscape as well. This is the work that I'm working with the engineer and architects to come up with the biggest rooftop in Asia. And it's actually coming from the local knowledge of rice terraces. We can motivate more ideas from the local wisdom that how we as a human used to live with nature harmoniously and put that with technology, and we better off with a new space, new place, new solution. We need a new solution, and that's how we together with Architect 2030, we need new innovation. Solar roof from this building pump up the water, slow down the runoff 20 times, and give us food, organic food whole year round. And also a case study for a younger generation. How many roofs can turn into healing garden, food source, and this is like what the first speaker has mentioned. We cannot build new all the time. This is an existing infrastructure in the city for 40 years. So we actually really put it into the pedestrian bridge, the park bridge across the river, and it's actually become a new landmark for Bangkok. So not just one benefit, but nature-based solution, landscape architecture solution can benefit many. Lifestyle of the people. But the most important thing is nature-based solution cannot do without people. We cannot just work from our office, but we need to talk to those who are in the front line. And our work in Bangkok, also working with informal settlement. This is people from Lat Pao Canal, which is flooded really heavily. When it's flooded, the whole Bangkok, this is the lowest part. And whole city of the water is actually go to their community to go to the river. So we need to work with them, talk to them. And this is another case study. We're working with the local government, learning the flood. This is nature flood. People need to move. Lots of money, maybe from Green Fund develop GCF to Thailand, but they actually end up building more dams. The red line is actually the line of the dam. The whole water is gonna to have amount of flood. So it's gonna flood more to the next community. So why we need to build dam? It's gonna flood ourselves. This is how we show as a landscape architect that the before and after impact when you change the nature, when you're not working with nature. This is how the lifestyle is gonna be. And it's gonna flood in front of the dam, flood behind the dam, and the lifestyle would change to the people of the global south. You fish, you walk across to pick the vegetable from your neighbor. You can't do that anymore because we're so afraid to get wet. And this is coming from the fear-based solution, not nature-based solution, what we are working on right now. And this is the picture from the canal in Indonesia. Some politician will say, oh, this is such a perfect, beautiful landscape architect of canal. No, this is like we are killing the canal, killing our river, not to move. And so from working with landscape architects needs so much for save the city in the global south. The engineer can do so much with the landscape. Working together, we come up with the green infrastructure. And this is where my regions belong. And this is how we're gonna flood soonly. And the sea level rise, South Sea intrusion. And I need to move sometime soon. According to the New York Times, maybe in 10 years or 30 years. So I actually would like to have our seat, our voice as a built environment designers, engineer, urban design, landscape architect, working together with policymakers, finance people, and all these people that to come up with the right solution, because the solution that you invest is multi-million projects. And those multi-million projects couldn't just be a short-term solution. We should create a future solution for the next generation to come. Plant more tree rather than buy air purifier for your PM 2.5. Plant more tree rather than just, okay, I don't want to get wet, let's build higher dam and higher dam and higher dam. So that's my take as a landscape architect, as a representation of IFLA and many landscape organizations around the world. So thank you, and let's work together.
Thank you, Koch. And that call to collaborate is something that I think all of you are addressing. So that will be a great thing to talk about at the end of the panel. Thank you. It's my great pleasure to introduce our next speaker. Imen Makhlouf is a civil engineer from Tunisia with 20 years experience in transportation and energy infrastructure across Africa. She believes her role, I love this, she believes her role as a human is to serve in her capacity as an engineer. And she wants to bring greater attention to climate challenges in the infrastructure design field. She is joining us as a delegate of the International Network of Women Engineers and Scientists, and she's personally an outspoken advocate for gender equality and empowerment of women. She says her superpower is empathy, and that's a tool that she uses to fully understand the problems her work is addressing. Thank you, Imen. And do you have the clicker?
Thank you, Lisa, for the introduction. A good presentation, my colleague Ghaith and Kotchakorn. So I'm going to present to talk about infrastructure facing climate change. But before going to my presentation, I want to introduce my three friends. Fatimata. She's 12 years old. She's from Comoros Island. In 2019, the cyclone destroyed her school. Kayla. She's from Gabon. She's 6 years old. Each day, she walks more than 3 kilometers with her brother to collect water. And Zainab, she is a Tunisian girl. She is 10 years old. She lives in a rural area. Flooding destroyed most of the rural area. So before talking about climate change and infrastructure, keep in mind my three friends. So we make sure that we leave no one behind. By 2050, the world's population is projected to be at 9.8 billion, and the urban population to almost double to 6.3 billion. This growth of population translates rise in water consumption, use of more energy resources, increase in electricity. Consequence, depletion on natural resources, overuse of global resources, water, food, forests, degradation of environment, global warming, rising sea level, climate change. So to support this increase in population, we need to address how to design and build the infrastructure in the most cost-effective and climate-conscient ways, to adapt design criteria and standards to address different cultures, priorities, energy resources, climate impacts, funding sources, and local priorities. Climate change impacts are increasingly being manifested through changes in atmospheric and oceans conditions. Continuous drop in rainfall, increase in annual average temperature, but also the upsurge in extreme events, tsunami, cyclones, sea level rise, droughts, floods, landslides, mudslides, rockfalls. So climate change have significantly impacted and overwhelmed existing infrastructure around the world. And the most impacted are vulnerable population. Access to clean water, affordable energy, safe transport are basic human needs. Around the world, millions of people lack of infrastructure, roads, bridges, water supply, to access basic services. It is thus important to pay attention to vulnerable population, provide them the basic infrastructure they need while mitigating climate risks. However, infrastructure is responsible of 79% of total greenhouse emission that contributes to climate change. Therefore, infrastructure must change to utilize less greenhouse gases, while at the same time, infrastructures need to become more resilient to climate impact. Therefore, addressing climate change in infrastructure design and is fundamental and plays a key role in achieving the UN SDGs. Infrastructures are designed and built to the code and standards that existed when they were constructed. However, embedded with these codes and standards is the assumption that climate is stationary. Now, with climate change, infrastructure design requires a reassessment of the relevance of the climate criteria currently being used to design all infrastructure. Infrastructures need to become more resilient to climate impact. Roads and bridges need to be built with different materials and are adapted to withstand higher temperatures and more powerful storms. Cities have to design and build a new system to prevent flooding in streets and transport infrastructure. Some regions have to find ways to limit landslides and erosions. What is the role of engineering for climate change? Infrastructure engineers have important role in addressing climate change and supporting climate-compatible development, in proposing nature-based solutions to address both mitigation and adaptation to climate change. Design infrastructure with consideration to impacts on the environment, climate, and respecting sustainable development goals. Adopt more regenerative design principle for complete infrastructure system that match the goal of becoming net zero economies by 2050. Existing norms must be revised to prepare engineers for the change required to address the impacts of climate change on infrastructure. Develop an early warning system of disasters. Utilize engineering to enhance disaster preparedness for effective response and to build infrastructure after recovery. We need more diversity of engineers with different skills, backgrounds, and culture. In conclusion, it is possible to design and construct fully functional infrastructure that are ecologically responsive, integrate natural material, green plants, and resources efficiency. We have all a role to play in building a more sustainable and equitable world. Thank you. INWES program is to encourage more women engineers to pursue and advance STEM careers so that they can have a role to play in building a more sustainable and equitable world. Thank you.
Thank you. Thank you. Thank you so much, Imen. That was wonderful. Now it is my great pleasure to introduce our partners from ASHRAE, and we're really lucky to have two ASHRAE representatives here with us today, Farooq Mehboob and Dennis Knight. Farooq is ASHRAE's president, and he's the owner of Mehboob and Company with offices in Karachi and Dubai. He's been active in design of more than 600 landmark projects across Pakistan, Central Asia, Africa, and the Middle East. And he's leveraged his influence to advance sustainable design in his industry. His superpower is his ability to connect people across difference, or as he puts it, to make friends out of enemies. And after having dinner with him last night, I can tell you for sure that that is his superpower. After witnessing the profound impacts of climate change on his home country, he's passionate about building resilience through the power of design. And Dennis is ASHRAE's treasurer and serves as an ASHRAE Distinguished Lecturer, chair of its International Standards Advisory Committee, and vice chair of its Epidemic Task Force. His experience in the design, construction, operation, and maintenance of high-performance buildings spans over 40 years and over 100 million square feet of commercial, federal, and industrial building stock. Thank you so much for joining us, Farooq and Dennis.
Good evening, everyone, and thank you, Architecture 2030, for having us. It's a pleasure being here. Building technologies in the global south have a rich history of relevant solutions to problems being faced today. So what I'm going to talk about is leveraging the solutions of the past to get to the future. The challenges which face the global south in addressing the crippling impact of extreme weather events resulting from global warming include a scarcity of financial resources, a lack of stable and reliable electric power, water shortages, and water shortages. Hang on, just give me a second. I'm not so good with computers. How do I slide this? Dennis, can I use your one? No.
Here we go.
Oh, all right. I'm just getting to my notes, so if you bear with me a moment. So we're talking about financial resources not being there, electricity and water not being available, and water quality being poor. And these are some of the issues the global south is facing. But the global south can leapfrog the development of technologies in the global north by employing passive strategies and utilizing high performance materials and equipment. So we take the solutions from the past, we apply the technologies of the day, and perhaps we can leapfrog to the solutions that we need today. So I'm going to share some examples of sustainable buildings from the past to just indicate that sustainability is not a concept that we've invented today, and it has existed for long periods of time. Here are some pictures of the Mughal fort at Lahore, which was built in 1556. And what does it feature? It features walls of brick and lime mortar, which is a very sustainable material. The U values for these walls are better than our latest standards today. And they had cool roofs to keep the buildings cool in summer. They had solar hot water, and they used screens coupled with misting fountains to combat the searing heat of the day and to cut glare. So most of these design approaches, which are passive, are applicable today. We must not forget these approaches, and we can develop them in ways in which they can be adapted and incorporated into modern buildings. Many countries are developing cooling plans as part of their commitments in COP, and these technologies can be incorporated in these cooling plans. Sorry, I need to go. Yeah. Here is a picture of the statues of Sima Malakaya, and this is a temple in Bera Lake in Sri Lanka, which was designed by Geoffrey Baba, who was a founder of tropical modernism, as he called it, a design movement with a sensitivity for local context, combined with form, which made modernism and synthesized it with the functional relationships and the environmental responses needed with material and light and air. And many of Baba's buildings work with natural ventilation using passive strategies. So these are just another example. Now, going forward, on the screen, you'll see the winning entry, which was a project from the Solar Decathlon in 2018 in the UAE. And this was a combined arrangement between the United Arab Emirates Water and Electricity Authority and the U.S. Department of Energy. And this building is the winning entry from Virginia Tech, which took first place. And it shows how traditional concepts of sustainability have been adapted to state-of-the-art versions. You see the screens, you'll see the double walls, the roofs are solar. There's so many of the features and strategies that were in old buildings have been brought in a 20th century concept here, 21st century concept here. So we learn from the past to build the future. And for the South, it's always going to be passive because of the constraints in resources in terms, as I said, of finance, of electric power, of limitations on water use. And that's where our friends from landscape architecture can help us greatly by making sure that the landscape architecture does not, as Scott said, eat up all the water. So I'm going to hand it to my friend Dennis for the next part of this presentation.
Thank you, Farooq, and thank you, Lisa, and all of my colleagues on the panel for putting this together for us today. So I'm going to talk to you a little bit about ASHRAE and let you know a little bit about us and what we're doing and what our members living and working here in the Global South are doing. So ASHRAE has been around since 1894. So we're 128 years old. We wrote, the reason we really were formed was to improve indoor air quality. And it was started with improving the indoor air quality of homes and residences that had unvented gas and wood-fired appliances and the things that does to us. So here in the Global South, we have 11,000 members out of our 55,000. So we have a large portion of our membership that actually work in India, Africa, South America. And all of those engineers, they live, they work, they play, they go to school and work in this area, and they're doing some amazing things that are already helping. We've had the energy code now since the 1970s to improve our energy efficiency. But here's some of our members, and they work with, none of us does any of this by ourselves, right? So we work with architects, engineers, civil engineers, landscape architects, structural engineers. Our members work in integrated design teams to advance those technologies and to help renovate, build new buildings, operate better. Operation is such a big key, and the key is to make these buildings safer, more affordable, more resilient, more energy efficient buildings. Our members are contributing to the development of adopting and adapting our standards. We write over 170 standards. We have about 5 or 6 that are really key and used worldwide, including the ASHRAE 90.1, which is an energy code and is being adapted by many of our local friends in the Global South to meet their local needs. So we're making our standards to where our chapters and members in the Global South are empowered to take those standards, figure out what works for them in their region, their climate, with their materials, and build better buildings based on their experience, their knowledge on the local communities. So one of the things this year, our chapters in Africa, in Nigeria and South Africa, participated in the UN's Global Alliance for Building Construction, the GABC, in creating what's called the Africa Roadmap for Buildings Construction, forging pathways to zero emissions, efficient and resilient buildings in the construction sector. Hang on just a second. I've lost my mouse. There we go. And so our chapters in Indonesia and Latin America are all working with the United States Department of Energy through their Net Zero World initiative to work all over the globe to accelerate clean energy and climate goals and to transition and transfer technology to each other and share ideas. So if any of us can do anything better or have a better idea, we bring it together, we collectively put it together and try to improve everything we do. We also are working with the Global Clean Energy Forum, which is 31 ministries in the Global South to share strategies and transfer technology. And finally, our International Standards Task Force is working to maximize the international impacts of our standards. And then last for me, before I turn it back over, I'll go through a couple of things, is Farooq and I have been holding with our board of directors and with our leadership global summits and industry roundtables around the world throughout this year to develop roadmaps and action plans to support a healthy and sustainable indoor environment across the planet. And lastly, we've just built a new headquarters, or actually we renovated a 1974 building. Again, using some technologies that Ghaith mentioned is to build less and not to build if we don't need to. So we proved we could take a 74 building, turn it into net zero energy, and we're going through our Scope 1, Scope 2, and Scope 3 audits right now and hope to be the first nonprofit organization to certify a net zero carbon emissions building here soon. Thank you. Farooq?
So, the last 30 seconds. ASHRAE is working to partner with, we're in discussions with the government of the UAE to develop an air conditioning solution which is based on solar heat and uses no water. And if that solution comes about, it'll be a game changer because it'll take away the factors of the shortage of electricity, the need to build power plants and emit carbon, take solar heat, turn it into air conditioning. So innovative systems and technology is the forte of ASHRAE. There are some of the other projects which we've gone. We're running out of time, but I'm just going to take the last one here. This is a building in Islamabad which is new. It's a corporate headquarters, and the walls are rammed earth 600 mm thick, and there are huge overhangs, courtyards, water spaces, all the things I showed you in the beginning in the fort, and those are applied in a state-of-the-art building. So ASHRAE, with its members, is working around the world to provide the solutions both for the global north and the global south. Thank you very much.
Thank you, Farooq and Dennis. And you mentioned a couple of things that I'm hearing sort of across the board. One is drawing on natural processes, and another is taking an asset-based approach. So I think those things we may want to talk about after the presentations. Our final panelist is Noella Nibakuze, who's the design director at Mass Design Group in Kigali, Rwanda, where she works in architecture design, building technology, and sustainability. She has a particular interest in projects that have a positive impact on vulnerable communities in Africa, and she hopes to improve people's lives through built environments that promote sustainability and justice. As a good listener, she seeks to make her projects culturally relevant by bringing community expertise to the table. And like Imen, she's passionate about supporting young women pursuing STEM careers. Noella said something in our conversation that really should have been the title of this panel. She said, "We need to build right if we are going to build more." Thank you, Noella.
Thank you, Lisa. So I'll be presenting to you an ambitious project we did at MAS, the Rwanda Institute for Conservation Agriculture, which I'm going to shorten for RICA. So this project was funded by the Howard Buffett Foundation, and it was supported by the government of Rwanda. And I'll use it an example to talk about building materials that are healthy and low embodied carbon. So for this project, Mass engineered, designed, prototyped, and tested local low embodied construction materials. Also, this university is expected to be the first climate positive university in the world by 2040. So we started by looking at the challenges Rwanda is facing that RICA can try to solve. Population growth and climate change are putting immense pressure on the land that we have. Rwanda is the most populated country in Africa, especially because it's small, and by 2050, the population will double, about 25 million, which means we're gonna have more people to feed and less land to farm. Also, climate change leading to long period of droughts and heavy rains that are damaging the infrastructure. The campus is located in the east of Rwanda, one of the hottest and arid area. It's about 1,500 hectares. We have about 69 buildings on about 150 hectares of land. And it's also home of the woodland savanna forest, the second one in Rwanda. There are only two. And the campus was designed on the principles of conservation, agriculture, and One Health. The mission of the campus, working closely with our partners, the government of Rwanda, RICA, and the Howard Buffett Foundation, is to train the next generation of leaders in conservation agriculture that attain healthy and sustainable food independence in Rwanda. So every decision we made in terms of design and construction had to reinforce this mission. So we asked ourselves, how can we balance One Health, low FAB, and climate positivity, carbon positivity. Being such a big site, we were particularly thinking on how we can place our buildings by using the land to the best as we can. As mentioned, the savanna forest that we left intact. This campus had also been home of an agricultural facility for many years. That means we placed our buildings on already disturbed soil. So we have our first-year housing or first-year farms and agriculture-based enterprises close to fertile soil. And we have our animal enterprises located on slopes and soils that were based for livestock. The government of Rwanda wanted that the students graduating here, about 80% should become entrepreneurs, come up with co-ops to influence the agriculture of Rwanda and internationally. So it's super hands-on. The first-year farms will experience the life of a typical farmer in Rwanda, really using traditional ways to farm. And as they move in their second and third year, they're gonna learn about agricultural value add from raw harvest to processing and to sale. This is a recent image of the campus. We have figure 8, which is the year 2 and 3, and the first year farms below it. So we wanted this campus to be hands-on by emphasizing on collaboration and mentorship. Another image showing further away the faculty housing, and much further on the west we have the enterprises and also housing, again really trying to emphasize on collaboration and social cohesion and mentorship between everyone. And in between we have farms, and we also have test plots to show some native plants that we hope the students will be elaborating on. So as we know, the building industry is the biggest contributor to greenhouse gas emissions. And per IPCC, in order to limit our temperature increase to 1.5 degrees, we need to halve our emissions for both operations, but also construction. So the campus was designed on the principles of low energy and passive design. So all buildings are naturally ventilated, natural lighting, also really taking advantage of the good climate of Rwanda. But also it's also 100% off-grid, where we have a 4-hectare solar farm feeding the whole campus, and we also extract lake water treat it and to be used in the campus for both potable and unpotable water. For this campus, now talking about materials, we were intentionally wanted to reduce the embodied carbon of all the buildings, and we achieved 2/5 compared to global institutional buildings of the same type. So RICA is actually towards half that is required per IPCC. And I want to show you how it was achieved. On my left, you have business as usual and what we did at RICA, where we really measured all the materials we used. So instead of using a steel roof structure, we used a timber roof structure. All our walls are non-fired earth walls, rammed earth and CCBs, and also a stone foundation instead of a concrete strip foundation. So this is a typical representation of all the buildings at RICA, where we have stone foundations, non-fired earth-based walling, compressed stabilized earth blocks and rammed earth, and a wood frame roof structure, and terracotta tile roofing. And this is for all the 69 buildings. So briefly about timber, we use timber for all our roof structures and some of the columns. And the timber really guided the shapes of our buildings, where you can see here we have the sawtooth. I will show you the butterfly after. But also because we insisted on the workmanship, we did not need any ceiling reducing the materials we had to use on this campus. So we choose timber over steel because timber is 1/10 of the embodied carbon compared to steel. And even the small embodied carbon we had in our timber was for all the steel connections. And this does not include the embodied in the timber in its raw form. We had to compare. As we know, steel, it's readily available, it's cheap, it's fast, and it's already proven durability. However, it has a high embodied carbon. And also, if we're choosing steel over timber, we're not supporting the local economy because all the timber was sourced locally or regionally. Just an image showing the rafters construction with the steel connections. This is another shape that we had, the butterfly roof from the timber construction. Earth was a big driver because our walls made up 25% of the entire structure of our buildings. So we opted for rammed earth and CSCBs. And from our early measurement, we realized that CSCBs are actually half of embodied carbon compared to other walling. But you can see that reinforced rammed earth is a little bit higher compared to concrete blocks. So we were intentionally on using the rammed earth on not everywhere, reducing the amount of rammed earth and increasing the amount of CSCBs. The supply chain was also very easy to trace because all the earth was from site, the 1,500 hectare site. So it's a long process, but this is the amount of calculation we went to measure the embodied carbon. And also realize that when you source locally, you can understand the impact you have both on the environment and on the people economically. While if you source far away, you won't really have that impact you want. All the blocks were manufactured on site as well. We had about 80 blocks manufactured per day, and the only foreign material was cement, which made up only 1/20th of the block made. This was to stabilize the earth blocks. Stone foundation, again, instead of the typical concrete strip foundation. And we realized that stone is actually 2/5 compared to concrete in terms of embodied carbon. And that will end that from what we learned at RICA using non-fired earth, we worked with the government of Rwanda and other institutions to come up with a guidance on how to use adobe blocks in the construction industry. Because even though this is a very old technique, we wanted to show that it can be used in a more formalized and safe way, and now it can be used in the whole country. We were also fortunate to plant about 40 hectares of native savanna plants on site, and that means the sequestration of the reforestation will make this campus climate positive by 2040. And I will end by saying that it's too late to do less harm. We need to remove what we've been putting in our atmosphere. We need to be regenerative. Thank you.